All right, welcome to Kerbal Space Program 1.8.1.2694. I'm joking. I don't know if I got those last four numbers right. Anyway, I know we are 1.8.1, right on the edge of 1.8.2, and that's nice. It was a little hectic for the modders. I think it's just one line of command code, too. Sometimes there's no effect, but the line of command code says, what version are you running? And then it spits back in the loop. Wow, camera issue. Okay, so it spits back into the loop, and then it comes and it announces to you, or it creates a situation in itself by which it denies being allowed to be used by Kerbal. And a lot of guys have overcome that by just making it all the way up to 1.8.9, no matter what they do, like advanced planning on your version check, which is ridiculous because we write software for other software that needs to be updated. So if we do this standard page file version check, it's just lazy programming. I mean, sure, you have to know how to wrap around all that, but anyway, it just means it's so important that we have our core programming conducive to, let's say, future modding, and we're not so fixated to what our teachers are telling us must be done, even though we have to have respect for the way the people before us did it. You know, they had a lot of limitations, they had their own ideas, and they had their own little nerdy, peculiar, backward habits too. Just like you and me. So if we can just think about tomorrow and what problems we're causing, it really helps us. And this is the us all taking responsibility for the little blue marble, or if you're standing on it, I guess it looks like a big blue marble, but if you put it into perspective, it's very small with a very thin atmosphere and possibly fragile. Not quite an egg, but not indestructible by any means. Anyway, I still don't believe in a carbon tax, even though I believe global warming is occurring, and we need to curb it with our behaviors and personal choice. I also believe that it's quite possible that the organic farming industry is burning out the black hole as much as the people pouring smoke off their chimney, and maybe a greater contributor would be recent volcanic activity on the Pacific Rim, even more so than animal flatulence or smokestacks can even dream to compete with. But we still need to study it as scientists and be aware. What I just said is personal and political and a statement from the point of ignorance. All right, all that stuff about global warming. I just know there's some snow studies, and we have some, carbon, and all of a sudden, like shoots off the charts. It's like, okay, natural, normal, little boop, boop, like volcano blows up, boop, boop. And we can look at 300,000 years of history through snow core studies. And then all of a sudden it just goes. So there could be a flaw with the snow, I guess. Maybe something happened and the snow started to get exposed. I know they've uncovered problems with carbon dating, and I know moon rocks create this issue. They thought carbon dating was down cold, and then we understand that radiation can change carbon dating. Constant bombardment of radiation can mess up we're shielded and protected by our atmosphere. Anyway, from certain harmful radiation that's converted. The spectrum is. So, not that the sun won't kill you by any means necessary. Okay, that's a pretty good rant. That was 4 minutes and 40 seconds. So, beautiful day. We get to approach the moon. Okay? This is approach and land on the moon as our current mission. Well, not land. We're supposed to stage 4, which basically means it's like a touch and go landing. For we don't actually have to touch our feet on the planet, but let's say you didn't have lander legs yet and you didn't want to land. And any craft we can make is probably going to have weak lander legs because we haven't progressed far enough yet. So the whole idea would be let me find a craft. Let's pretend the bottom of my screen is the moon. So you come in, beep, 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 beep. All of a sudden you're flying like as fast as a bullet around this thing almost in orbit. And so what you have to do is turn around and fire your retro rockets straight against what we call your direction of travel, and you go and then you're going to slow down. Now as you slow down, you're going to tilt and adjust, and eventually you're going to just freeze yourself above the ground below you in space, and then the gravity well of the moon is going to grab you and pull you straight in. Okay, at which point you don't have atmosphere, so you can't use your parachutes. So as you come in, you have to fire your rockets and slow yourself down till you feather touch on the moon. It's retro rockets. Elon Musk is doing it now with the Dragon in Earth atmosphere. We have such powerful gravity and we have such thick air that this is not really feasible, nor has it been feasible on Earth. We're coming in, like I demonstrated, 7 times the speed of a bullet in our 1/10 atmosphere. You can only imagine in real life. Bullet travels, 700 miles per hour? Or am I so messed up it's 700 meters per second? I do all this meters and miles, and I'm in a country that uses Fahrenheit. I go Fahrenheit, Celsius, meters, feet, yards, miles, kilometers. It's kilometers per hour, miles per hour. Temperature 0, temperature 32, freezes hard at 100. Boils at 100, 212, freezes hard at 0 minus on Celsius. So each system has its merits scientifically from a perspective, but I don't know which one we should use. And the only thing I can think is all sides should know all things. Like if you're a metric only country, come on, get over it, man. Learn Fahrenheit, not just a class you take at school and go, oh, this is weird. But seriously understand that our water starts to turn into ice at 0. Okay? Our water, Fahrenheit turns into ice at 0. It starts to turn into ice at 32, Fahrenheit 32. Centigrade is 0. Okay, now, but here's Fahrenheit. We freeze solid. The atomic particles actually stop moving at our 0. So there's a range between 32 and 0 in Fahrenheit. Well, your range is between 0 and minus whatever it is. I might have to look it up. I don't want to speculate. But so our range isn't just where we start at 0. Is it where ice begins to form, or is it where molecules freeze hard? Now they say centigrade's the scientific language because it's water starts to freeze at 0 and begins to boil at 100. Well, they should have pulled that 0 down to where molecules stop, because in the sense of science, Fahrenheit almost makes more choice, because there's a point where water begins to boil at 212 in Fahrenheit, 100 in Celsius. But at what point do the molecules start to come apart? That's it, actually, where you steam, all that stuff. You're turning your water into vapor, and then it's going to change its state. You're not creating it or destroying it. You're just changing it. But at what point does it just evaporate into thin air? That's funny. Thin air. Whoever created that was standing in the heaviest air on the planet. And they're like, evaporated in thin air. See, they were so ignorant they didn't even know there was thin air or thinner above. Anyway, science is so much fun, and people are so goofy. They know wrong things. They have strange ideas. Stupid stuff comes out of our mouth. Not really stupid. Let's call it ignorant. That just means from a perspective of the unknown. I'm just basically talking without knowing. Whereas the opposite, and that's what we always try to get here, is what we call a perspective or a contextual perspective, which comes with understanding the terminology, understanding the concept behind it, practicing within this world, and making it so you can explain it to others. And then the explain it to other part is probably the next step. But you'll need a contextual perspective before you can even begin to explain to others. Otherwise, you're just, what do we call that? A blithering idiot. And that doesn't mean as bad as it sounds. If you look up the word blithering, it just means some kind of unintelligible talking. An idiom is about the unknown. So you're basically babbling of the unknown. You're a little baby, is what they're called. A blithering idiot is basically a baby. You're a baby. It's a way to say you're a baby. It does not sound nice at all, but it's not as bad as it sounds. Don't ever call your teachers that, even if they say it wrong, even if they're teaching you wrong things. Now, if you say it about a little, maybe 1-year-old baby, go, bow, 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 you go, oh, look, a blithering idiot. And adults hear you, you will be a genius. Okay? But anyway, okay, so am I still ranting? It's at the 12-minute mark. I always rant for about 12 minutes, and then we get on with our mission. But okay, so our whole goal is to stage a landing to the moon, and I actually came in here and played with the craft. Let's look at this thing. Alright, that's not the craft I played with. Is it possible? Oh, here it is. I made this ridiculous thing here. Just wanted to see if it would even fly. And what I found out is it seems to be way too top heavy. So I think the only thing I can possibly do, and this is going to be an experiment, of course. I really wish I could show you the behaviors. But basically, it gets to the point where you have to fire. Oh no, oh no, oh no, I didn't want to do that. Stop right there. Alright, I need to get a little closer. I'm trying to grab this. There we go. What happens is it gets to the point where I have to fire the bottom engine, and it's too top heavy, or it's not aerodynamic enough. So this could be creating an aerodynamic problem right here. This is a big thing sticking out. So what I might do is move this over to here. That's not bad. And what this does is the aerodynamic nature is going to come cutting down this way, and it won't be hitting that light on the very point. And this flat top could also be causing a problem. But one simple aerodynamic adjustment may be all I need to create that top heavy situation. Alright, and then 6 of these at the right point. I think they're a little low. I'm not sure how this is going to turn out, but let's go ahead and give this a shot. I'm going to take a seasoned scientist and seasoned pilot with me. I have nothing really to reset, so I don't need the scientist with me. So what I'm going to do is pop him off and get Bill Kerman some experience. Let's take an engineer. Alright, so I need to take just a short break. You won't notice it, but when we come back, we're going to go to launch and take off. This is the 15-minute mark. Alright, izvinite, malenki problema. Small problem. Anyway, I just took a break. You don't know it, but in America, or the United States, we teach our children to say number one. In Russia, they say malenki problema. Yeah. Oh, anyway, I have a problem. I have a small problem, they tell their parents. And you can only guess what a big problem is. We have a secondary number. I'm just talking code, but I think it's a cute cultural thing to teach children. Discretion. Discretion in public. How to talk, how to control, how to sound civilized. You know? Urinatsia, defecatsia. I'm not translating those, sorry. Alright, I don't know what's going to happen. I know it was no good in my first build and test flight phase. And I was rolling at inappropriate times. I'm not sure if I have my thrust value adjusted. I think I may have put my thrust value on 90%. That's just to get a longer burn out of my solids. Anyway, let's go ahead and check my staging. It looks all messed up. Alright, and I don't know if my parachutes are programmed. I'm going to have to check that later. Alright, that twist is not good. That means we are somehow lacking. If you see how it twists, what's wrong is we don't have enough thrust to lift the weight. So we have to reduce our weight somehow if we have to go back to the drawing. We're also doing this nice little natural tip to the 270, which is the wrong way around the planet. I'm going to have to give it some gas. It looks like we're going into the inevitable roll. So we have to be ready for that. And I'm going to try to correct right now. Alright, cut off the gas. And when we come back to the top, turn it back on and go. Turn it off. Go. Turn it off. Trying to get to the blue. Go. Alright, giving it gas, giving it gas, giving it gas. Now, trying to get over to 90 and control it. Look at me at 90.45. I'm fighting it. I'm fighting it. Alright. I've got 35,000 feet, which is wrong. I'm not supposed to be there till 40, so I'm going to try to milk it back up to a more straight up direction. Okay, that's called rocket roll. Usually we have a guy on the self-destruct button. Alright, I got to go back on my power. Sorry. At 48, I'll need to get to 45. He's the range operator, the rocket range operator, and if that rocket's turning back, coming towards us, he usually has a way to self-destruct. At 55, we move into the 30-degree range. Up to 61, we can start going on down to about 5 or 10. Alright, now we are flying this rocket by the seat of our pants. This is not efficient by any means, and I'm slowing my speed down. I'm trying to get control, but I think that gimbal on this big powerful engine, that's the gimbal's the thing that makes the thrusters move. They're helping us control. I'm starting to lose control. I'm just going to go for assistance right here. I'm at 67,000 feet. I'm at 36 seconds to apoapsis. I'm at 88 degrees. azimuth 90-degree directional, 89-degree directional, 10-degree in my glide slope azimuth, approaching 70,000 kilometers with approaching 15 seconds to apoapsis, 1,200 meters per second. I am only in an upward direction of 100 meters per second. I need gas, all of it. And I'm probably going to run out of gas before I need to, which is great, because we're not going to create space junk here. And I'm only going for 2250, mind you. Ooh, it didn't like that. It does not like its current state for some reason. I'm trying to get to the point where I'm at going 2250. And I'm having problems because I passed my Apple. Oh, shoot. I passed my apoapsis, which means I'm up here in the upper atmosphere. But I am not efficient with fuel right now. I'm fighting the auto control, sorry. So anyway, we're going for 2250, which we just hit, and we realize we need more. And I'm going to put it up on about 75, 35, 41, 49, 50, 67, right here. Okay, so that's at 70. I'm going to place it here and put it on 75 for some reason. 75. There we go. Now, I'm going to turn everything off. And what we're taking is an upward ride to 75. We hope. Let's look at our map. Alright, so I'm approaching my periapsis, or my lowest point right now. But after I reach that point, it should start to take me in an upward direction. Actually, it will. And you can see our 75 is coming down. Let's get out of here. Look at it over here. Our 75 is coming down, but by the time we actually get there, we can just put them both on 70. We're at the 23-minute mark, and we have unofficially almost achieved orbit. Now, if you're even worried a little bit about coming backwards, like we're not going to make it, just put it, we're here again, put it back on 75. Just go, psh. See? Put it right back on 75. I used hardly any gas to do that. Okay, so we've just hit the center, and you can see we're going to start flying up, not down. You see that up here in the glide slope, or the vertical ascension-descension meter, the vertical speed meter. How fast are you going up and down, which is different than our forward speed. Our forward speed is 2309 meters per second. Our upward speed is almost nothing, between 1 and 5 meters. And this is also in meters per second. Everything we do is in meters per second. You can see we're down to 73 already, so that adjustment may have been good. But at this point, we're flying up. So, and as you can see, as we start to fly up, and as our own altitude increases, you will see that this number's decline is going to slow down. Like, look at this. We're looking at this number right now. I'll look at the number before that, the 0.765, 4, 3, 2, 1, 0. Alright, I'll do that again. 8, 7, 6, 5, 4, 3, 2, 1, 0. I don't know if you saw, but it took me longer to actually talk about that. One thing you can do is place your rocket straight up. Let me go ahead and turn some power on. Place your rocket straight up like this and just point this directly. That's with our thruster pointing straight at the planet. Okay? And you can see we're getting ready to fall below the 70. So what I do is I pull that. By pushing it straight up, I'm elongating this. Alright, and I can put that all the way up on 82. And then I'm going to come to here. And you can see this number's in decline. And this number's in decline, but as soon as I get into space, I'll just make an adjustment. And this is basically adjusting for rocket roll. This is when you over-engineer your craft or you underthink it. I actually know what I could do to fix this, and it'd probably be as easy as putting fins somewhere, but when those engines come off, they had a destructive power. They probably ripped my fins right off. Anyway, it's just in the early phases. Maybe we need to learn about rocket roll. Ooh, you see my gimbal lock? If you ever saw that Tom Hanks movie, Apollo 13. Don't let them gimbals cross. Don't let them gimbals cross. Gimbal lock. It's not that big a deal. You're not going to get thrown off into space. Just have to shut down one set, get control with the other, kind of manually coax it. You can see my gimbals fighting with each other right now. It's doing this rocking motion, and you can see it's actually settling in the middle where one gimbal wins. But as a lander, oh good, see this number's almost stopped declining at all, and so has that number. It must mean we're in space. Oh good, we're in space, so good. Let's go ahead and increase our time frame. And then as we approach that, let me show you something. What we did before was face the planet up. Now let's point our nose right at the face. See what happens there. Okay, so I don't know of any other simulation edutainment program. Some people call this a game. It's technically classified as a game when you try to go buy it or find it in Wikipedia. But it's a subgenre, at least, edutainment simulation programming. And that's because you can play with the space-time continuum in the universe. So as I point straight down and fire this,